Look at this gross looking inequality. Well, I see two distributed properties, so let me take care of that first. Negative x is negative x. Negative positive 2 is negative 2. I'll drop down the 5x right here while I'm at it, is greater than. Negative 5 times 1 is negative 5. Negative 5 times x is negative 5x, and then drop down the positive 3. Now that we've taken care of distributed property, let's combine on both sides separately. So 5x minus x is 4x. That gives me 4x minus 2 is greater than. Negative 5 and 3 combine, so those combine to make negative 2 and then minus 5x. Now I have variables on both sides of the inequality. I prefer to have my variable on the left. So I'm going to add 5x to both sides, add 5x to both sides. That crosses out. 9x minus 2 is greater than negative 2. Now, this is good news. Why? Well, since I have negative 2 on the left and negative 2 on the right, by adding 2 to both sides, they both cross out, leaving me with 0, and it's about to make my life a whole lot easier. Because the last step is to divide both sides by 9. And when you divide both sides by 9, let me write it over here, 0 divided by 9 is 0. So my answers are going to be any number greater than 0, but not including. So let's draw our 0 and our other numbers out like so. Let's forget the negatives. And when I graph my circle at 0, it's an ugly negative 5. I'm going to make sure that I don't fill in the 0. So here's my 0. Don't fill it in. I want everything greater than that. So let's shade heavily to the right. And what this means is I'm allowed to take any positive number like 1, like 50, like 3.5, and plug it into all of the x's in the original equation, and it'll end up being a true statement. Okay? So pretty crazy inequality, but pretty fun too, right?